And the first question that I want to address, it's one that we've addressed before, is what is machine learning? So there is a little bit of repetition here. Machine learning is a field of study within AI, tasked with the development of generally iterative, not always, but generally iterative, statistical methods and algorithms that accept training data, learn relevant patterns and relationships from that training data, as well as generalize and apply those learned relationships to new cases or new data sets. We may visualize machine learning like repeatedly shooting a free throw, something I think we've all done at least once in our life, right? We make small adjustments to the way that we shoot until consistency is achieved. We shoot the ball, it goes too far. What does that mean? We have to reduce the strength with which the ball was thrown. And that strength, we can equate that to a variable. And what we can see is that machine learning employs a very similar process. It tries out inputs, compares the ideal and actual results to one another, and then adjusts the variables in order to improve performance. Let's say we shoot the ball too far to the left. Again, that's another variable we can adjust. We can aim our body more to the right. And what happens if we make the shot, right? If we succeed, then we want to do nothing. We don't want to adjust any variables. Before we can apply machine learning, there are several questions that must be considered. For example, do we have labeled training data that facilitates supervised learning if we want to use supervised learning? Or do we prefer to use an unsupervised approach, such as that associated with clustering? What model should we employ? A logistic regression model, a neural network? There's many different options there. How can we maximize the effectiveness of the machine learning model and optimizer by properly initializing variables like the synapse weights, by increasing or decreasing the rate at which learning occurs, and or increasing or decreasing the connections between nodes? And this again obviously would only apply to a neural network. Specifically, this module focuses on implementation of a supervised machine learning algorithm that employs a basic error correction rule in conjunction with a single layer perceptron neural network for binary classification. Now, it may seem like I just threw a whole bunch of terms at you. However, each one of these terms is one that we discussed in a previous module. Now, I did quickly want to introduce the process that we're going to use for this type of supervised machine learning, and we can boil that down to about 6 steps or so. The first step is to make sure we understand the problem and the objective. Second step is to define the machine learning characteristics, and we are going to clarify exactly what we mean by a characteristic. Step 3, to collect appropriate training data. That's very important. We can't really achieve much success in machine learning if we don't have good training data. Step number 4 is to train the model, and we can actually break that down into 4 sub-steps. The first of those is to evaluate the model to generate an estimated output. The second is to update synapse weights, and this would assume that we're dealing with a neural network model. If it weren't neural network based, then we would just simply call those parameters. Step C, or step 4C, is to check for convergence. We're going to talk about what that means later. And if we achieve convergence, then we're done.